Quick review on solving and graphing linear inequalities. Remember, inequality is comparing symbols greater than, less than, greater than, equal to, less than, or equal to. Big thing here is make sure that you know that everything that makes an inequality true is called a solution. So any value that you can plug into that inequality and make it a true statement would be considered a solution. We also had a little key here. The key showed the four symbols, what they represent, and if they had open or closed circles. Remember, open circle meant value not included, and closed circle meant the value is included. And the last big piece here that a lot of people tend to forget is that anytime you multiply or divide by a negative number, you have to reverse or flip the inequality sign. So we'll just give you two basic general examples solving inequalities here. The first example that we have, we need to get x by itself. Remember, your inequality sign acts as a equal sign, so that's determining the two sides here. So we need to get x alone, so we would add 19 to both sides to start. We'd have 9x is less than or equal to 18. Get x alone, divide both sides by 9. Work down our paper, and we have x is less than or equal to 2. So then we go ahead and make it on our number line here. So here's 2, 4, and 6. Down here we'd have 0 and negative 2. Looking at our inequality sign, the inequality sign that we have is less than or equal to. And in our key, that says that it is a closed circle, which tells us that the value is included, so 2 is included. Now you need to determine what way the arrow goes. The easiest way to think about this is determine what can I substitute in for x to make that a true statement. I always tell people to use extremes. So if you look at your number line, 100 would be way on the right. Negative 100 would be way down on the left. So let's say I took one of those values. Let's say I substitute 100 in for x. The problem would say 100 is less than or equal to 2. That is not a true statement. 100 is not less than 2. So our arrow would not go towards 100. It would have to go the other direction, away from 100. And all those values to the left then would be considered solutions that would make this inequality true. Last example, example 2. Same scenario. Need to go ahead and get x alone. So I'm going to go ahead and subtract 12 from both sides. Work down my paper. I have 24 is less than negative 2x. Get x alone. Here I'm going to divide by negative 2. Now remember, when you multiply or divide by a negative number, in this case I'm dividing by a negative 2, your inequality sign has to reverse or flip. So I flipped my sign right there. If you don't do that, your inequality will be incorrect, as well as your graph. Work down the paper here. We get negative 12 is greater than x. Same thing. Go ahead and fill in a number line. And on negative 12 there, look at our inequality sign. Our inequality sign is a greater than sign. So that means it is an open circle, meaning the value is not included. And then you use the same technique, all right? Way down here on the right, 100, negative 100. Take one of the values, substitute in for x. So let's say in for x here, I put in 100. Is it a true statement? Well, negative 12 is greater than 100. Not a true statement. Negative 12 is not greater than 100. So we would not go to the right. We would go to the left. This would conclude our review on inequalities.